So hello Mr. Lee, so this is the fifth time for me to record a video essay for you, and so let's go back to the graph initially. So this is my new graph, and I set up these points on it. So this is point A, FA, and this is point A plus H, FA plus H, as I mentioned, and I have drawn a tangent line on point A, FA. This is the first step for me to label these points, and then I'll move. Actually, I'm about to like demonstrate the steps one by one by the rank which you instructs us on the Schoology. So here is the step 1 and the step 2. It asks us to illustrate and correctly label the sequence that correspond to the preceding intervals. Okay, so over here's the second line I draw on these 2 points, which is A plus H, FA plus H, and AFA. So regarding the preceding interval, it means it defines that we should move from left to the right. So over here, the point A plus H, we just assume that H is an absolute value. So by the time H is a negative number, it will be on the left side of A over here. But rather, if AH is a positive number, then this point should be moved to the right side. So from this point, we can get a conclusion that by the time H is a negative number, so it will be on the preceding interval. But instead, if H is a positive number, it will remain on the following interval, which is from on the right side, from the right to the left to the point. By the time it should approach it, and the same as the case 1, H is a negative number, so from the left to the right to approach this point. So, and there's one thing I want to mention, that we can see that by the time the point A plus H, FA plus H wanna approach this point, so the secant line should be increasingly approaching the tangent line as well. So following that, let's moving on the third step to it said divide of the formula for the slope of this secant. So I've mentioned the formulas over here. So the first step is which we have learned last semester in the advanced function class for the slope of secant. So fb minus fa divided b minus a. So in this graph, I'll substitute these 2 points in it. So fa plus h minus fa and a plus h minus a. So finally, we get this conclusion: fa plus h minus fa divide h. But nevertheless, we should satisfy a circumstance that by the time the slope of secant should be approaching the tangent, a slope of tangent. So we can see that this h, the value of h, should be increasingly approaching to 0, because look, here's what I wanna demonstrate at the next steps about the rate of change. So on the next step, it asks us to explain and illustrate how to derive the IRC formula using the limit specific to the graph. Okay. So actually, regarding the preceding intervals I just mentioned, we should the value of h should be a negative number, and we should from it will approaching to point A from left to the right. So these points are made by me for illustrating the rate of change to you. So by the time h approaches 0, so we can see it is very increasingly approach point A and look very close to this point. So that in this circumstance that the limit h approaches 0, we can just use the formula of the like the slope of secant, combine the function to get our final limit formula, which is over here, the ultimate step. Lim h approach 0, fa plus h minus fa divided 0. Okay, so let's move on to the fifth step. So explain how to generalize your work with proceeding intervals to get the overall formula. So that I just mentioned that lim h approach 0 is necessary because of the slope of secant should approach the slope of tangent, and h should approach 0 actually. So on the right side of the formula, first of all, let's see fa plus h. So the value of h I just mentioned will be like we will consider the preceding method if h is a negative number, and rather we should consider about the following method which h is a positive number. So no matter just I mean regarding the the following or preceding method, we just try to, no matter from the left side to the right or the right to the right to the left, we just need to focus on one point by the time we wanna calculate the slope of tangent. Yeah, we only focus on one point. So actually there's also some unusual cases for us that not allowed us to use the limit formula over here. Please give me a minute, sir. I'll find out the graph. Sorry. Yeah, over here. So actually, sir, I decided to remain in this graph because I wanna add some knowledge on the graph to show the unusual cases on it. So first of all, we just directly move on to the right side of the graph. So as I seen to all, here is a vertical asymptote over here. So first of all, I will use two methods to prove that on this point the slope of the tangent does not exist actually. So first of all, let's use knowledge of the limit formula which I mentioned before, and I'll combine it with the first of all I'll combine it with the formula of the secant, the slope of secant actually. So let's have a look over here. So I just as mentioned that the by the time we need to satisfy calculating the slope of secant, we should make sure that we have 2 points. For instance, 1 point over here and 1 point over here. So, but going back to the formula of the slope of the tangent, we only have 1 point over here, and I just assume that I have a point over here, a plus h, and the h is a negative number. So by the time I supposed to calculate the slope of tangent over here, I will let h increasingly approaching 0. So from the left to the right, so over here to here. So actually, no matter I draw the a plus h over here or over here, no matter it's a negative number regarding the preceding method, or it's a positive number regarding the the following method from right to the left, or over here from the left to the right, it should all approaching on 1 point. But nonetheless, on the vertical asymptote, there's no points for us to use because there's no points on this line. So from this point, we can see that it is unnecessary for us to use limit formula on it. So it slope of tangent on it does not exist actually. And furthermore, I will mention another step uh, actually regarding the proceeding and the following. So as we all know, from no matter on the proceeding or the following methods, from left to the right, from right to the left, it is a little bit similar to what I just said on the first step. They should approaching one point. But right now in this graph, we can see that if we use the proceeding and the following, they will get two distinct answers, and actually the two distinct points on this line. So it is not worth that it is inaccurate for us to calculate the slope. So that it also intensely proving that the slope on the like the when the x approaches 4 does not exist. Let's go back to the left graph. It is absolutely very appropriate for us to calculate no matter the slope of secant or slope of tangent. So over here, here's a point. I just assume that this point is a plus h or this point is a plus h. They will increasingly approach this point by the time with the limit h approach 0. Or we just use proceeding or following, it will also be approaching this point. So that's what I want to mention in my video essay right now. So and also by the time this is the end of my presentation. So thanks so much, Mr. Lee. Have a nice day.